Here we go with more examples on section 2F, rates. You might remember this is where we're going to draw a handy dandy chart that's going to help us out. We're going to read the problem, make sure we understand what they're asking us to do, and then we're going to go fill in our chart. This says rate. We're going to put our rate in this column, the amount that we're dealing with in this column, and this is going to be a multiplication problem. The rate times the amount, that is going to equal the last column, which is the quantity. So in this column, we're going to put our players. And in this particular problem, I hope you've had a chance to read it. We've got oranges and we've got peaches. So if we want to, let me go grab the blue guy here. If we want to put oranges in this box and peaches in this box, our titles for the rate are going to be calories per fruit. How many calories per fruit? The amount is going to be the number of fruit. And that is going to equal the total number of calories, because the fruit cancels, cancel fruit, and you're left with calories. I'm sorry, my writing is just terrible. That says calories. Hopefully your writing will be better. So filling in our table, we're going to go back and we're going to look at what they tell us here. They're saying that an orange has 30 more calories than a peach. So again, I'm going to let X equal the number of calories in a peach. So that's what this is right here, the number of calories in a peach. So if there's X calories in a peach and an orange has 30 more, then we can represent the calories in an orange with X plus 30 equals calories in an orange. So I can fill that in right here. And it doesn't matter whether you put the peaches first and the oranges second, however you want to set up your table. Turns out the same. Now we go back, and this is the number of calories in a fruit, the amount of calories in a fruit. So, no, this is how many fruit there are. So there's 7 oranges, 7 pieces of fruit that are oranges, and there are 13 pieces of fruit that are peaches. Now we're going to just do our multiplication straight across. We're going to multiply, and we're going to end up with our quantity over here. This is the calories in this many pieces of fruit. So that's 7 times, green's not good, let me switch, 7 times X plus 30. Don't forget your grouping symbol. We're going to be doing some distribution here. And this is 13X. So that gives us a chart that's nice and filled in. Now we need to go figure out what our equation is going to be. It says find the number of calories in each fruit. So it says 13 peaches have the same number, there's your equal sign, of calories as 7 oranges. So if I can represent the calories in 13 peaches, 13X, that is going to equal the total number of calories in those oranges, which is 7 times X plus 30. So this is an instance where you're setting these two last column quantities equal to each other based on this sentence right here. This sentence and this 7 gave us the information for the chart. This sentence right here gave us the information to solve our equation. So now we can solve the equation, we can distribute, and we can get 13X is equal to 7X plus 210. You can subtract and get those X's together, move the 7X over here, come over here, and we end up with 210 equaling 6X, divide, and you get X is equal to 35. And I can go back up and I can say, oh yes, X is the number of calories in a peach. So 35 calories in a peach. So I can go over and make my answer. Maybe I'll put it up here. 35 calories per peach. And if I go to my X plus 30, which is the calories in an orange, I take the 35, add it to the 30, and I get 65 calories in an orange. And that's the answer. Okay, let's see. I am going to skip this scrambled egg problem, and I'm going to give you another problem. I'm going to insert another problem because I think your particular handout is a little bit different. I will come back to example number 7. Let's run on to example number 8. This is a real common kind of problem that you'll see on standardized tests a lot, collections of coins and how much they add up to. So again, we've got not dimes and nickels. We know how much they total up to, and then we know something about the quantity of dimes and nickels. So we're going to set up our chart. Let's see what we're going to do here. If I can make a chart, should have probably already done this. I'm going to go like this. And this is going to be dimes. These are our players, dimes and nickels. Dimes and nickels. And then we want to know for our columns, we are going to put the value of the coin, the value in one coin. So a dime is worth 10 cents and a nickel is worth 5 cents. And this is going to be, so this should say value, and this is the number of coins. And of course, when you multiply together the value times the number, you are going to get the total dollar value. I'm making a big mess. Okay, so we go back to the problem and we're saying we don't know how many dimes and nickels we have, but we know there's 24 more dimes than nickels. So I am going to let X be the number of nickels, and I'm going to say X plus 24 is equal to the number of dimes. So I can fill that in my chart. Nickels is X, the smaller amount, and X plus 24 is the amount of dimes. Multiplying straight across to get the total value, you have 10 times X plus 24, and you have 5 times X. So I didn't really even need those parentheses. So this is the total value, and it says the total collection is worth $4.50. That's going to give us the information that we need to set up the equation. So if you take the total value here, which is 0.10x, I'm going to go ahead and distribute, plus 2.4, move the decimal point, and add that to the 0.5x, 0.05x here, that's going to equal $4.50. We can combine our like terms. You've got x's, you've got 0.10 of them here and another little bit more here. Don't make the mistake of thinking this is 0.015. It's 0.15 x's, or 0.20. I've seen people add 10 and 5, and I don't know what the common mistakes are, but just be sure that you've got your decimals going right. 0.15x is equal to, or plus 2.4 is equal to 4.5. Subtract 2.4 from both sides, and you get 0.15x is equal to 2.1. Divide, and you end up with x is equal to 14. So x is the number of nickels. So there are 14 of those nickels. And there are x plus 24, so that gives you, it gives you the answer for the number of dimes. But notice this problem doesn't even ask you how many dimes there are. It asks how many nickels. So you really are finished with answering the question right now. Now, if you want to check your work, then obviously you'd go back and you'd figure out, well, there's, 24 plus 14, that's the amount of dimes, and you'd go calculate the value and make sure you could get back to $4.50. Okay, I'm going to stop this video right now, and then I'm going to come back and get you a decent example 7 and be back with a couple more examples. Thank you.